Good afternoon and welcome to the fourth installment of this webinar series presented by Enable Training Consulting in conjunction with our friends at National Instruments. This is Ben Zimmer from Enable Training Consulting, and I'm sitting here with
Greg Sullivan. Hello.
And we're looking forward to talking with you today about the teleop and autonomous templates. Let's begin with a bit of a review from the previous webinar, in which we really focused on what was necessary to get your robot moving in the context of an FTC competition. And so for that we need a field control system, the Samantha module, and we did a very brief introduction to using the code templates, and of course running the code within the field controller system. This time we're going to go into a lot more detail about what's inside the code templates and how to modify and create them. Last week we talked about the FCS software. We gave a quick tour of it, understanding how it can be used to allow 4 teams to communicate via their Samantha modules from one computer. We talked a little bit about the Samantha module itself, explaining how it's used to convert Wi-Fi to USB to allow us to drive our robots using a Wi-Fi connection. There's various options and configuration methods that we talked about. We also talked about the purpose and the need for the code templates within the context of the FTC competition, that they allow you to build your code without worrying about programming specifically to handle the enable-disable state of the FCS, for example. We also saw what the field control system software looks like when it's running a game. As mentioned, in this webinar, we're going to go into a lot more detail about the teleop and the autonomous templates themselves. We're going to talk about how to generate the teleop code, as well as how to modify and test it. And we'll also look at an autonomous code example. At this point, I'm going to hand control over to my colleague Greg, who's going to give us a little tour and explanation of how to create the teleop code.
Thanks. Okay, so generating teleop code. To generate the teleop code, we use the remote control editor. We set up all our desired hardware settings in the remote control editor and click Generate Code. So I'm going to go over to LabVIEW right now. And as we see here, under the remote control, there's a default configuration file that is automatically going to be there when you create a new project under the FTC bot template. So it's already going to have a lot of its configuration set up. It's by default it's tank. We'll just go ahead and hit arcade left here, and if we go to our configure robot action, we can actually see that there are already a bunch of predefined actions set for our buttons that control our arm and gripper. And we did talk a lot about the remote control editor in the first webinar. One of the things that we didn't talk too much about is the actual actions that we can set for our buttons. So let's take a look at some of the options available just on button 1. We have the move while pressed function that's available here. And as we can see, we get an alert on the left here. This is because right now our left and right wheels are being occupied by our arcade left drive function that we've already set up. So by trying to control it with another button, we're going to have conflicting information. So a lot of these actions here are only going to be useful to you if you have extra DC motors that you want to use on your robot. And as it sounds, move while pressed, the motor is just going to move at a given speed for as long as you have a button pressed. Move for time is going to be a predetermined time, again for a motor. Move for distance, you're actually going to need an encoder if you want to use that, as well as an extra motor, and that will move a specific distance on the press of a button. Move to position is for servo motors, and that is what is actually already predefined for our buttons here to control our servos. The advanced sub-VI action is something that we're going to talk about a lot more in depth later, so I'll just show it to you here, but we won't talk too much about it at this point. The change drive power is just going to allow you to change the overall speed of your robot at the press of a button. So the next thing we'll talk about is actually generating our code. Now that we'll just use the default setup here. with our button actions already defined. And at this point, all we can do is run it live here. We can test it, but we can't actually do anything with the underlying code. So how do we get that code to deploy for an FTC match? All you do is hit generate code. It'll prompt me to name it now, and we'll just call it Teleup mode, and hit create, and that'll take a little bit to generate here. And what this is actually going to do, it's going to take all of our configurations and all of our settings, and it's going to give us a VI that can be deployed on the brick and run independently from our computer here. So here we have our Teleup code that's been generated by our remote control editor, and we can see that there have been cases set up for our buttons, and it takes account all the previous actions that have been defined. So now I'm going to hand it back to Ben, and he's going to talk about actually modifying this generated code.
Great. Thanks, Greg. I think it's worthwhile, as many of us and many of our key programmers on our teams are going to be interested in understanding exactly how this works. When we took a quick look through the templates last week, we saw these same three functions, and we're going to, again, bring up our context help with the Control-H shortcut, reading the latest packet, getting the connection status, and disabling or enabling the robot. We've got some code here that we really shouldn't mess with, that's essentially serving the purpose of reading the overall state of the robot from the FCS, and if it's enabled, allowing it to then proceed. So the output of those three functions is to determine whether or not the system is ready to go. And of course, that gets fed into the input of a case structure. So we see right now we're looking at the enabled state of the case structure. And if we were to jump into the disabled state, well, not so surprisingly, there's very little in here. There's no function, there's no movement functions, but there is something here which will display the battery voltage. So it's not advised that you put any code here, because essentially your robot's not supposed to be doing anything. Certainly you will not pass robot inspection. But if everything is great and ready to go, then we'll be operating in the enabled state here. So what's important to understand is that this code that was created here was done automatically when we clicked the Generate Code button. And it was based on the configuration options we had for our controller settings. And this is an absolutely fantastic way to get started. And it's worthwhile just taking a quick look at exactly how this code operates. So bringing back our context help, we've got a function which is reading a packet, followed by a function that's reading the button states. Then we've got a for loop here. And what this for loop is doing is looping through all the various button states that are read, and then performing actions depending on the states of those buttons. So if you think of the purpose of this for loop, it's essentially flipping through all those button states and making a decision. Within each of those button states are two pieces of information that are being used here. And this function we're looking at here is called an unbundle. It's essentially a way to take multiple pieces of information out of a type of data that's called a cluster. And within a LabVIEW program, a cluster is similar to a struct in many traditional programming languages, which is a way to basically bundle together a bunch of different information onto one wire. And so once we've done that, we can pull out the button ID and the event type. And we can then, as we're flipping through each of those results, we're choosing which button we're looking at. So the first time through, it may return button 1. And the value of button 1, if it's pressed, the behavior, if button 1 is pressed, is to adjust the drive power to a maximum of 75. And if it's not pressed, or rather it's released, you see that there's no action. So this is basically the format that's used to make decisions based on all these button states. And as it's flipping through all this information, from button 1 to button 5 to button 6, 7, and 8, if we look at any particular one of these, we see that button 8, for example, when it's pressed, is doing a move servo command to a position 80 on our gripper motor, on our gripper servo, which is exactly what we've asked it to do, or rather what the default configuration is asking it to do. And also down here, below the for loop, is our drive function. The interested student or the interested programmer and mentor can dig inside these sub-VIs and take a look at exactly the math and how it's happening. For now, we'll just understand that it's taking a drive power and our readings from our packet and making some decisions as to what speed to give the left and right wheel. And right now we see that it's picked arcade left. If Greg had not modified the selection from tank, it would still be set to tank steering. So when we make the appropriate decisions within the control editor and then we generate code, it's automatically scripting or automatically creating this block diagram. So what's nice is once the block diagram has been created, what we can do is we can actually make modifications on here. And what this is a somewhat more advanced topic, and one we're definitely going to go into a lot more information on in the advanced topic at the end of this webinar series. But we can make modifications right in this block diagram to, for example, change the behavior so that an additional button is handled. So what we're going to do as a quick example of that is notice that button 2 is not handled here. So I'm actually going to add another case and another case structure inside that to perform a certain behavior which is going to initialize our servo positions whenever we press button 2. So I'm going to start off in my outer case structure, right click and say add case after, and by default it's picked button 9, but I can redefine this by just typing in to be button 2. And now we only want the particular action that we're going to perform to occur when the button has been pressed. So this event type conveniently is already available here. So we again go to our programming subpalette, structures palette to pick out our case structure, create a case structure here, and wire the selection terminal to our event type. Because this event type has got two possible cases, pressed and released, those are automatically pre-populated. So the code that we want to create, we're going to put right inside the pressed case. So what we want to do, as I mentioned, is we want to initialize our servo positions. So we're going to right click to our Tetrix palette, to our Tetrix move servos command, place it down, and there's two pieces of information we have to give this guy. We have to tell it which servos we want to move, and then we have to tell it which positions we want. So I'm going to right click on the servos constant to create a constant. I'm going to pick my two servos, which of course are arm, and then I'm going to click the triangle to expand a second one to choose gripper. Now that we've got arm and gripper, two choices selected, we automatically get two input terminals for our positions. I'm going to right click to create a constant on my arm position of 25, and on my gripper position create constant of 200. What that's going to do is when my teleop code runs, if I ever press button 2, it's going to put our arm and gripper servos to a known position of 25 and 200 respectively. So this has been a very simple and short demonstration of how we can manually make changes to this block diagram to achieve functionality after we've clicked the generate code. So we'll dive back now and go on to the next step.
Okay, so we'll go back to our PowerPoint for a second here. And we talked about generating. We just talked about modifying the code and how we can get outside of the constraints of the predetermined actions from the remote control editor. Sorry. So the next step is testing this teleop code. The remote control editor can be used to test and deploy our teleop code that has been generated and modified. And this is going to allow you to run and test code without the FCS software. So if we go back into LabVIEW, you notice that because of all the FTC code, generally you wouldn't be able to run your code without an FCS initializing it or telling it's okay. So a way to test it is actually to go back to our Robot Project Center, open up our remote control editor, and under the Run Program, we can actually click FTC Game. And we can make our robot think that the FCS has given it an OK to run. And if we open up this selected program here, we can either download and run any programs that are inside our robot project currently, or we can just run VIs that are saved on the brick already. It's hooked up with USB and is communicating with it. So we'll go ahead and we'll click teleop mode. And if we hit Start Test, it's actually going to compile and deploy our code to the brick. That'll probably take a few seconds here to compile and load up. And there it's been downloaded to our brick here. And now, as soon as we click enable, now all of a sudden, if you looked at the brick, that's when you give the command on the brick that it thinks the FCS has given it the OK. So now you might be able to hear it going there. I can if you see the stick on the screen here, live readouts, I can also press my buttons here to do my predefined actions that we've set in the remote control editor. And also, when I press button 2 now, it is just raise the arm and open the gripper, which is exactly what we just manually modified our teleop code to do. And then we can go disable and stop test. And you can see that this is a very quick and easy way to test out all your modified code without having to worry about going back into your FCS and worrying about all your Wi-Fi setup. It's just quick and easy. Do it over a USB cable, over Bluetooth, and you don't have to worry about the FCS. So now I'm going to hand it over to Ben, and he's going to talk about the autonomous code templates.
That's great. Thanks, Greg.